In this video lecture, you will learn about non-deterministic finite automata, that is called as NFA. So what is non-deterministic finite automata? Here, non-deterministic finite automata implies that the machine can exist in more than one state at the same time, and transitions could be non-deterministic. So as you can see here in this example, from state Qi, for input symbol 1, there are two transitions. For input symbol 1, either the machine, if I give input 1 if the machine is in state Qi, the machine can go to either in Qj or Qk. So let us take one example. If I say I have three states in my NFA, so Q0 is the start state, and there is one intermediate state Q1 and a final state Q2. Okay, and if I give input A here, machine is going to the state Q1, and for input B from Q1, if I give input B to Q1, machine is going to Q1, and there is a self loop for A and B here, and there is a transition for input A here, and again there is a transition from Q2 to Q1 for input B, and there is a self loop for A here, and there is a transition from Q0 to Q2 for input A and B. So this is the transition diagram for NFA. So here to start with, the machine will be in the state Q0 because that is the start state. And if the first input is A, okay, so the machine can enter either in state Q1 or it can go to state Q2, because you can see here from state Q0 there are two transitions for input A, and in state Q0 if we give input B, the machine enters into the state Q2. Similarly, from state Q1 there are multiple transitions on input symbol A. You can see here from Q1 there is one transition from Q1, and there is one more transition for input symbol A. Okay, so there are transitions to the state Q1 as well as Q2 for input symbol A from state Q1, and the machine machine can enter either to Q2 or it can stays in Q1 only. So at this point of time we cannot determine the exactly in which state the machine will be. So this is called as non-deterministic finite automata. So this is transition diagram, or we can say the transition graph for an NFA. So that is the basic difference between DFA and NFA. So machine can be in more than one state at the same time. So that's why we call it non-deterministic. Now we will take we have taken the example. Now we will see the definition and how it is different from DFA. So as you know, in DFA also we have 5 tuples. So in NFA also we'll have 5 tuples: Q, sigma, Q0, F and delta. So capital Q will be the finite set of states, that is same as DFA. Sigma will be the finite set of input symbols, and Q0 will be the start state, and F will be the final state. And we know that for any finite automata there will be always one start state and at least one final state. So how it is different from DFA? Only the transition function will be different. So here we are saying it is a mapping from Q into sigma to subset of 2 to the power Q. Why? Because if we say DFA, so DFA, if I say Q0 is the current state, and if I give input A, the machine can be in one state only. Okay, that is DFA. But if I say NFA, for any given input, machine can be in more than one state at the same time. So I can say Q1, Q2. Okay, so then this is NFA. So here we were getting the single state. Here we will get set of state. So if it can be like, if I say there are 3 states in my NFA, Q0, Q1 and Q2, and if I give input A to Q0, so machine can be in Q0, it can go to Q1, or it can be in Q2, it can go to Q2 also. So that's why here we are getting 2 to the power Q. So we know the transition function, there are two parameters of the transition function. First one is current state, and then the second parameter is input alphabet, and the output is the next state. So this current state we are going to get from set of capital Q. Because it is a finite set of state, so it will be capital Q. Input alphabet we are going to get from the symbol sigma, and then here we are in DFA we were getting only single state, here we are going to get set of state, so that's why it will be subset of 2 to the power Q. Okay, so that's why this transition function is written like this for NFA. Now let's take some example how to construct NFA for a string containing 0, 1. Okay, so when we say string containing 0, 1, so we have taken the same example for DFA. Now how to draw NFA for the same example we will see here. So string containing 0, 1 means the language will be only 0, 1 is a valid string, or I can say 0, 0, 1, this contains 0, 1 as a substring, or I can say 1, 0, 1, this is also fine, this contains 0, 1, or any number of 1 and then 0, 1 is also fine, or any number of 0 and then 0, 1 is also fine, or any combination of 0, 1 and then 0, 1 is also fine. So all these are valid string. Okay, so what is the minimum length string here? Minimum length string is 2. This 0, 1, the length is 2. So to accept string of length 2, I need at least 3 states. So Q0, Q1 and Q2, and 0 and 1, it should be accepted. And then we are saying before 0, 1, I can have any combination of 0 and 1, so self loop. After this 0, 1, I can have any combination of 0, 1, so self loop I am putting here. So this is NFA. You can see here from state Q0 for input 0, there are two transitions. That means if I say delta Q0 0, what I am getting? I am getting Q0 Q1. So I am getting set of state. So this is NFA. Same thing for the same transition graph. This is the transition table. So the same way we are going to draw the transition table. Q0 is the start state, Q2 is the final state. For input 0, I am getting Q0 Q1. For input 1, I am getting Q0. And from Q1 input 0 we have not shown. In case of DFA, it is necessary to show all the transition from each state, but in NFA it is not necessary. So we are getting 5, we have not shown the transition for input 0 here, and for 1 it is going to Q2. From Q2 0 and 1 both it remains in the same state, so it is Q2 only. So this is how we can draw the NFA. Let's take one more example. So why it is non-deterministic? Because you can see here from state Q0 for input 0 there are two states Q0 and Q1, so that's why it is non-deterministic. So here build an NFA for the following language. W language contains all the string which ends with 0, 1. Okay, so when I say ends with 0, 1, so only 0, 1 is fine, or 0, 0, 1 is fine, 1, 0, 1 is fine, or any number of 0, 0, 1 is fine, any number of 1, 0, 1 is fine, any combination of 0, 1 and 0, 1 is fine. See, all these are ending with 0, 1, or 1, 0, 1, 0 and then 0, 1. So all these are valid string. So minimum string is 0, 1. So to accept string of length 2, I need 3 states at least. So 0 and then 1, and 0, 1 is a valid string, it should be accepted, and we are saying it should always end with 0, 1. So beginning I can have any combination of 0 and 1. So self loop of 0, 1 if I put. So that means in the beginning any number of 0 or any number of 1 or any combination of 0 and 1 will be accepted, but it always end with 0, 1. So this is the NFA for the given language. And here like DFA, we are not checking the transition from each state for all input symbol. Like from Q1 we have shown the transition for 1, 0 we have not shown. Similarly from Q2, 0 and 1 we have not shown. So for NFA you can give some other solution, equivalent solution also. Okay, so this is not the only solution. You can come up with some different solution also, but provided it should accept all the valid string. So hope you have understood the concept. Thanks for watching.